Here we have a couple of examples of quadratic equations. We're being asked to solve the equations by completing the square. The first step, when you have a quadratic equation set equal to 0 like this, the first step is to move the constant term to the other side of the equal sign. When I move that minus 3 over, it becomes a positive 3. I'll bring down the other two terms, and then I have a space here. That's the first step. Step 2 is to take the term that is next to the x to the first variable, this coefficient, 6, take the coefficient there, I'm going to cut it in half. And that gives me, what 6 over 2 gives me a 3. Then we square the 3. We take half of that center coefficient and we square it and we put the result up here. That's a plus 9. Well, I've changed the left side of the equation by adding 9 to it. To keep the balance, I need to do that to the right. All right. So on the left, what this gives us is a perfect square trinomial. If you try to factor the left side, you will see, remember when you factor trinomials, you turn it into two parentheses, and you've got an x, and you look at the 9. What are the factors of 9 such that when you add them, you get the 6 in the middle? Well, the factors of 9 are 3 times 3, and 3x and 3x certainly gets us back to 6x in the middle, so we know we're right with that factoring. 3 plus 9 on the right side, I should take care of that. That's 12. So on the left side, we have this perfect square trinomial. That means I can rewrite it as x plus 3 quantity squared equals 12. What we do now, I'm going to rewrite it down here, just so you see the individual steps. And I'm going to take the square root of both sides. Now remember, when you take the square root of both sides, you need to include a plus and minus on one of the square roots. And so on the left side, the square root of a perfect square just gets you the x plus 3 there. Now we have plus or minus the square root of 12. That can be simplified. The square root of 12 is really the square root. You look for a perfect square in there. 4 is a perfect square. 4 times 3 is a factor. So we get plus or minus. The square root of 4 comes out as a 2. Square root of 4 is 2. Left inside is the 3. We're not able to bring that out. We have the x plus 3 on the left side. So now we move the 3 over, and we get x is equal to minus 3 plus or minus 2 roots of 3. I'm going to circle my answer. That's as far as I can go with that one. The next example is very similar, but it'll probably involve, it looks like it's going to involve a fraction. Recall what the first step was? See if you can remember. What did we do on the left side? We moved the constant term over. X squared plus 5x. I think I'm going to leave that as a separate step. And then we drop the 5, we cut it in half is what we do. Make that 5 look a little better. We take the 5 and we cut it in half. And what did we do over here after we cut it in half? If you look at the left side, you had 6 over 2. Well, that was 3, and then we squared the 3. Well, 5 over 2 doesn't reduce like 6 over 2 did, so I have to leave it the same, but I still have to square it. And I'm going to put the result up here. And so the result is going to be, I'm adding the result, and it's going to be 25 over 4. That's what it means to square 5 over 2. 5 squared is 25. 2 squared is 4. And because I've added something to the left side, I need to keep the balance and add it to the right side as well. On the left side, this is now a perfect square trinomial. What do we have? X times x. What times what is equal to 25 over 4? Well, this is going to look familiar because it's 5 over 2. 5 times 5 equals 25, and 2 times 2 equals the 4 in the denominator there. Well, that's how we got it, squaring 5 over 2. And the signs are plus. On the right side, we have 2 plus 25 over 4. Well, 2 is really 8 over 4. So if you think about this, 8 over 4 plus 25 over 4 is 33 over 4. All right, and so now we have this perfect square trinomial, which I'm going to rewrite as a perfect square, 33 over 4 on the right side. Do you recall what we did next? I'm going to rewrite it again. Not that you have to keep doing these rewrites that I'm doing. I'm just doing this to show that to keep the different steps visible on the notes here. But if you recall what we did, this is where we took the square root of both sides and putting in the plus and minus. So the square root of this left side is just the x plus 5 over 2. And that's equal to plus or minus square root of 33 over 4. This simplifies on the right side. That's plus or minus square root of 33 over the square root of 4, but the square root of 4 is just 2. I'm going to move that 5 halves to the right side. I want to solve for x, meaning I want x all by itself. Pull that plus or minus out in front this time, over 2. So combining them, noticing they have the same denominator, the common denominator, this is the simplified answer. I'm going to circle that answer. All right, I'm going to take it down to one that's a little bit more interesting because it has a leading coefficient. That 3 in front of the x squared is a leading coefficient greater than 1. You know, these other ones that we had up here, if you recall, if you notice, the leading coefficient was just 1 on the A and B examples. Now we have a leading coefficient of 3. It makes it a little more interesting. I'm going to rewrite it just the way I did last time. I'm going to move the 7 to the right side. It becomes a minus 7 now. I'm going to factor out the 3. Kind of force factoring because 3 is not a factor of 8. But if I put 8 over 3 here, then I've factored it out. I'm going to leave this parentheses open. I'm going to put a minus 7. I'm going to continue with the minus 7 there. Now, why does this work? Okay, well, notice that if I multiply the 3 back in, you know, will I get back to the previous step if I redistribute that 3? Well, I get 3x squared by multiplying 3. And if I multiply 3 times 8 over 3, the 3's cancel, and I'm left with the 8, well, with the negative in front still. But the 3's cancel, leaves us the 8 in front of the x. So that's correct. All right, now we need to do this process where, you know, it's kind of an algorithm. You take this 8 over 3 and you cut it in half. You notice I'm still writing 8 over 3. Cut it in half. Well, I think the easiest way is just to multiply it by 1/2. You could divide it by 2, but that's really the same as multiplying it by 1/2, and it's much easier to see when you do it that way. You're going to get 8 over 6. 8 over 6, I'm going to go one more step before I put the result up here because that reduces to 4 over 3. That's a better thing to do. And then if you recall, what we had to do was square that and then put the result in. And so that's going to be 16 over 9 when you square that. And I'm adding it. Now you might be tempted to add 16 over 9 here to keep the balance. When we added this 16 over 9, or when we added values above, we just added them to the right side to keep the balance. But I'm really not adding 16 over 9. Yeah, it looks like that right here, but if I multiply 3 times 16 over 9, I mean, that's what I have to do. There's this 3 out here that distributes to 16 over 9. The 3 cancels. I have the 16 over 9 with the 3. That 3 cancels with the 9, so really what I've added, when that 3 cancels, what are you going to end up down here in the denominator end up with? The 3 and the 9 cancel, you end up with a 3 down there. So I'm really just adding a 16 over 3, and that's what I'm going to add over here, 16 over 3. That's exactly right. That's what we're doing. So now we have 3 and a perfect square trinomial. I'm actually going to be able to factor this. It's x times x gets me the x squared. 4 over 3 times 4 over 3. So better make that x look better. 4 over 3 times 4 over 3 gets you the 16 over 9. I'm not going to put plus and plus because we have a minus here. It's minus and minus. Minus times a minus is also gives us that plus. So minus 4 over 3x and another minus 4 over 3x is minus 8 over 3. So we know we've got it right there. Let's see. Minus 7, I need a common denominator of 3. That's really minus 21 then over 3 plus 16 over 3. All right, and then we have 3, and this is a perfect square, so I'm going to write it as a square there. Minus 21 over 3 and plus 16 over 3. That gives us a minus 5 over 3. All right, well, I'm going to get rid of this 3 at this point. Some people do get rid of that 3 earlier on. I didn't, so I'm going to get rid of it now. I'm going to multiply both sides by 1/3. I mean, you might be tempted to divide by 3, but then you're going to end up dividing by 3 over here. Why don't we just multiply both sides by 1? And in doing that, 3 times 1/3 is just 1, so we are now down to the x minus 4 over 3 quantity squared. And here we have minus 5 over 9. Now, if you recall, I'm going to make this a separate step again. Just rewriting what I had, and now I'm going to take the square root of both sides. Put a plus or minus in front. So we get x minus 4 over 3 is equal to plus or minus the square root of minus 5 over 9. That's to say that x minus 4 over 3 is equal to plus or minus, splitting this radical, square root of 9 is positive 3. Now we're getting, if I move the 4 over 3 to the other side, I'll get a positive 4. It's going to have the same denominator. It's positive 4 over 3 plus or minus. The minus 5 becomes I roots of 5. And that's the answer we circle.